Okay, so unit exam review here. Okay, kind of stuff that's going to be important for your unit exam. First thing we went over was that we reviewed the difference between scalar and vector quantities, reviewed what things were scalar, what things were vector, and reviewed the use of V equals D over T. Now, could there be some multiple choice questions about scalar and vector quantities? Definitely. And it could be simple things like, if I'm describing something, is this a scalar quantity or is it a vector quantity, or, which of the following are not vector quantities, or, something along those lines. Definitely some multiple choice questions, just assessing whether you know which things we've gone over are vector and which are scalar. Okay, so scalars and vectors for sure. Okay, and we talked about these here as our scalars: time, distance, speed. We didn't really talk about energy and work, but they're in the next unit. Okay, they're both scalar as well. And then for displacement, okay, that's a vector quantity. Velocity is a vector quantity. Acceleration is a vector quantity. Okay, so we need to make sure we know those. Not just because there could be multiple choice questions, but in a situation like this, just in case it happens. Not saying it will, but yeah, just in case. Let's say I have an acceleration problem for you to solve in the written response part of the test. Oh, incidentally, I do. There are two of them. Okay? And the question goes on about, and here's this given, here's that given. I give you maybe VI and D and A or something like that. Okay? And then I ask, calculate the final velocity. And you go through all of your calculations, you calculate the final velocity, and all you write is 5.2 meters per second. You getting that right? Nope. I asked for velocity. What did you give me? Speed. Yeah, no vector on it, not velocity, not right. Okay, that's where you need to know your vector quantities. Okay, more for the problem solving than for the written or for the multiple choice. Okay, make sure you know, oh, that's a vector quantity. I need to make sure that I make that negative in this question. That could affect all my calculations. Those kinds of things are why you need to know which things are vector, which things are scalar. Okay, that day we also reviewed the use of V equals D over T. Now, I am not going to burn a 5-mark written response problem to test your ability to use V equals D over T. I already know you can do that. Okay, maybe there might be a multiple choice question worth 1 mark that involves a V equals D over T calculation, but not a written response item. That said, V equals D over T is part of what that we've been working on lately? Projectile motion. We have to use V equals D over T for the horizontal part, so it's definitely a formula you need to know how to use. All right, so that'll be how scalars and vectors will be covered on your unit exam.
Will we have the formula sheet for the unit?
Sorry, I couldn't hear you.
Will we have the formula sheet for the unit?
The formulas are on the front page of the exam. Okay, you cannot use your formula sheet because I have no idea how many notes to self you have written on it. Okay, so you will get a, basically it's the same thing that's on your formula sheet, all that kinematic stuff, just put it on the front page of the test. Okay, so no, you can't have your formula sheet, but you do get a formula sheet, right? Okay, second thing, graphing. Probably worth some of the biggest marks on the entire test. Okay. What 2 graph types did we go over? Position versus time and velocity versus time. There are several graphing questions in the multiple choice. The ones in the multiple choice are mostly interpretation. So here's a graph, what's the object doing kind of questions. Okay. And in the written response, there is a position versus time graph and a velocity versus time graph written response item. Okay, and they are each worth, I want to say between 6 and 7 marks. Okay, and they have like an A, B, C, D. Oh, we might even have an E. Okay, I've asked you to do a lot of things with those various graphs. I'm going to ask you to do all of those same things on the unit exam. So, go over your 2 labs. If I asked you to do it on the lab, I'm going to ask you to do it on the exam. Okay? That would be things like using using y equals mx plus b. Okay? Finding slope. understanding what slope represents, okay? Being able to calculate displacement from either type of graph, okay? Being able to calculate acceleration, okay? Being from velocity versus time graph, being able to calculate velocity from a position versus time graph. All of those kinds of things, okay, are going to be tested on there in exactly the same way that I asked them on your labs and in the worksheets we did in class. Okay, so make sure you go over that stuff because it's important. Okay, so just some quick stuff here. I'm just going to erase that and do this over again because it's way too messy. Okay, if I have a position versus time graph and it looks like this. So this would be meters, this would be seconds. Okay, and I've got that line. What's that object doing? Not decelerating, nope. Moving at constant velocity. Which way? Backwards. Yeah. Okay. Its position goes from a large positive value to a less large positive value. Smaller, not less large. Not good. Anyway, okay. It's definitely moving backwards at a constant velocity. Okay. If this question were to give you this, let's say, could you be asked to calculate some things using that? You could, okay? I might ask you something like, what would the position of the object be after 20 seconds? That may or may not be on the graph, and you would have to calculate it using the equation, right? Or I could ask you, how long will it take for the object to reach position 0? Okay, and you would have to calculate that, right? So definitely know how to use y equals mx plus b. It's going to be part of the calculations you're going to be asked to demonstrate, okay, on the unit exam, okay, using a position versus time graph, right? Or I could have a position versus time graph, and it could be not linear. Maybe it would be like this, something like that, okay? And I might ask you, you know, what's the total displacement? Calculate it, okay? Obviously, you wouldn't be using y equals mx plus b for that because it's not one single line. Now you might be using, you know, final position minus initial position, and v equals d over t, and stuff like that, okay? If it's not a linear line, then you don't use that, okay? Now, if a question gives you this, does it give you that for a reason? Yes. And in fact, if I give you a question with the equation on the graph, in the question, I will probably say in bold-faced, italicized, underlined font, using the equation for the graph, solve for this. What should you do? Yeah, everyone says, use the equation, Mr. Codere, until exam day comes, and then people decide, oh no, I'm going to do something else, even though this question says exactly what Mr. Codere is looking for. Okay, guys, if it says, do this question this way, do it that way, damn it. Okay, that's the way I want you to do it. Okay, I'm trying to get you to demonstrate your ability to do it that way. And, spoiler alert, I will have set it up so that if you do it a different way, you won't get the right answer. Okay, it's easy for me to do that. So, if the question specifically says, solve this way, solve it that way. Okay, that's me trying to assess that particular skill. If you show me another skill, I'll go, good for you, that's a nice skill, not what I was testing. Okay? And you don't get any marks for that. I know that sounds really sarcastic, and it is, but it's also true. So just make sure you do it the way the question asks. Okay? All right, so that could be how position versus time graphs could go. Okay? You're also going to have a velocity versus time graph problem on there. Okay, so if I had a velocity versus time graph that looked like that, which is exactly what our graph looked like in the acceleration lab. Okay, I would probably give you this again. This time, let's say it's going to be alright, so I give you that graph with that equation, and I say calculate the acceleration. Okay. How many marks would that question be worth, do you think? 1. Why? It's right there. Okay? This is a velocity versus time graph. Does the slope of the line on the velocity versus time graph represent acceleration? All you would have to do is write that number down. Okay? It's a 1-mark question because you're demonstrating to me, hey, Mr. Coderre, I figured that out. Okay? I didn't have to do any calculating, but I knew what it was. Okay? Incidentally, something to look for on your test. If a question is out of 1, how much calculating does it require? None. Okay? The answer is there somewhere. Don't show me 5 marks worth of calculations. They're probably not right. Okay? If a question is out of 4 marks, then there's probably some steps and some calculating and things like that. Okay? Let that help you a little bit when you're on the test. Look at the point values. They'll be in brackets at the end of every question. If it's a 1-mark question, there's no work to be done. There's just a number to write down. Okay? If there's many marks, then there is some calculating. I'll be looking for some steps. Show them to me. Okay? All right. What else might I ask you to calculate from a velocity versus time graph? Displacements. Okay, and we talked about that on our lab. Okay, that if we have a graph that looks like this, we can use a lot of the equation if we just use that formula. Okay, we're looking for d. Okay, part of this equation represents vi. Okay, part of it represents our acceleration. Okay, and our time we can always read directly off our graph. We can very easily solve for that, okay, using what the graph and the equation give us. Right, so keep that kind of stuff in mind. All right, so like I say, fair amount of marks on graphing on your unit exam, so be ready for that. Okay, acceleration is the next thing we went over. There's some simple calculation stuff in the multiple choice. Okay, that like no manipulation involved. Also, there's some multiple choice questions that ask you about the nature of acceleration. Okay, could be combined with a graph. Here's a picture of a velocity versus time graph. What's the object doing? It's accelerating. It's not accelerating. Okay, things like that. And then there are 2 acceleration problems in the written response. Okay, so make sure you can use your acceleration formulas for those. And you'll also have to use your acceleration formulas for projectile motion. Okay. All right. Vector addition. Okay. There's a few multiple choice questions just about the techniques and principles behind vector addition. You know, like the whole tail to head thing and stuff like that. Okay. So there could be a few in the multiple choice, not that would involve any calculating or anything. But there could be a few situational questions in the multiple choice that would involve, or that would be testing your understanding of how vector quantities work, okay? And I would refer you back to the Walmart trick we talked about that day. We went over that in class and talked about, if I walk to Walmart, then I walk all the way back. What's my displacement? What's my velocity? Stuff like that. Okay, so there could be some questions that are talking about that in terms of vectors. Okay, and then obviously in the written response, I've told you time and again that you're going to have a vector addition problem. 1 vector angled, 1 vector not angled. Put them together, get me the resultants. Okay, that kind of thing. So definitely you'll see that in the written response. Okay, so like I said, tail to head. Okay, boat question. We'll go over a few of those. A few. Okay, and there's one on your test. I won't tell you whether it's rowing across or going across, but there's a boat question on your unit exam. Okay, so make sure you go over those. One thing about the boat questions, and it got a few people on the vector assignment yesterday. If the question, the boat question says, give the heading measured from the shore, okay, or relative to due east, I think is the way it was written on your vector assignment, it's looking for one of them in particular. And in that case, both are not right. Okay, so if it says it wants the angle measured from the shore, it wants this angle. That's the one that's measured from shore. This angle is not. That's measured from perpendicular to the sheet. Okay, so make sure you read the question carefully, because once in a while the question states it wants that angle or that reference. Okay, so just be on the lookout for that, because you could do all the calculating, know exactly what you're doing, but because you haven't read the question carefully, you don't get full marks for your answer. All right, and then the last thing we went over was projectile motion. There's one of each kind. There's a horizontally projected projectile, and there's an angled projectile, one of each. Okay, and they are not going to surprise you. They are exactly like many of the questions we have done in class. Okay, I didn't pick one that was weird, like find the throwing angle, okay, or something strange like that. I picked ones that we've done 100 times. Well, probably not 100 times, but 20 for sure. Okay. On your multiple choice, okay, you're going to get the zip grade sheets. Okay, you guys have all used those before? Okay, just the bubble sheets. Okay. You don't have to use pencil on those, but I don't know why you wouldn't, because if you screw up in pen, you can't erase it. And my camera on my phone only sees bubbles that are filled in. It doesn't understand when you do this, when you go, oh, it's B, and you fill that in, and then you're like, oh, no, it isn't. It's actually D, and then you do this. My phone sees that as wrong, because there aren't two correct answers. Okay, so when I scan it, it just says that question is wrong. Okay, it gets even worse when people do this. Oh, it isn't that one. It's this one. My phone can't read. Okay, you can tell when the bubble's filled in or not, but it cannot read, and it doesn't understand that. And I don't go back over it. Okay, do it in pencil, erase it completely. Okay, if you need to change your mind. My suggestion is always, when you first go through the multiple choice, just do that, put a little mark in the middle, and then when you're all done, go back and fill them in. Okay, so that if you need to change any of them, it's an easy change, as opposed to, you're scrubbing like crazy to try and get that one out.
Are we allowed to go through lunch time when we write the test?
I will let you write a little bit over the end of class, yes. Okay. That said, the test is designed to be written in an 80-minute period. Okay, so you shouldn't require a whole heck of a lot of time beyond that, but I will let you have a little bit now. Of course, if you have through learning support, okay, extra support, like extra time through learning support, you probably already know that. I already know that too. Okay, if that's the case, of course, you will be provided with those provisions. Okay, if they apply to you. Okay, same with if you have a provision for the text-to-speech. Okay? If you have a provision for text-to-speech and you're going to use it, please make sure you bring your own headphones. Okay? I'm not going to give you some like rental, dirty, gross, COVID-infested headphones for you to use. Okay? So if that applies to you, make sure you have your own headphones.
Maybe you've already mentioned this and I just didn't hear. How many questions are on the test?
I have not mentioned that yet, and I will. Yeah. All right, so just make sure, guys, that you're filling in the multiple choice correctly here, okay, in the proper way. Okay, so how many questions are on the test? No, it's less than that. Okay, it's less than that. Okay. Oh, that's right, I whittled it down. It's only 17 multiple choice. It was originally 21, and then I was like, that's a little bit, I'll take it too long. Okay, so 17 multiple choice, and there are 7 written. Okay, so 7 written response and 17 multiple choice. The 7 written response items add up to 48 marks. Okay, so there's a number of them that are 5 or more marks. Okay, like your vector addition one is going to be more than 5. The graphing one's going to be more than 5. Okay, stuff like that. So as I was saying before, you have both types of projectile motion problems. Okay, you got a boat question, you got an acceleration problem, got a velocity versus time graph, you've got an a vector addition problem, and a position versus time graph problem. Okay, so that's what you're looking at. Well, that's right. You know what? There aren't two acceleration problems because I took one of them off. I was feeling like the test was too long. So I took one problem off and 4 multiple choice. Now it feels short, but I'll keep it that way. Okay. So that's what you're looking at there, guys. Okay, and as I said, with the multiple choice, okay, various things about scalar and vector quantities, displacement and velocity, displacement versus distance, velocity versus speed, okay, graph interpretations, stuff about the nature of acceleration, vector addition principles, and principles behind projectile motion. That's what's in there. Okay. All right, questions from you guys? Anything you want me to go over, clarify, maybe problems you want me to solve from any of the worksheets we've done or anything like that? Okay, I take requests. Except for singing, you don't want that.
What's the types of boat questions like that you deal with?
Yeah, 2 types of boat questions, sure. All right, so the first type of boat question that we went over is a rowing across question. Okay? So in a rowing across question, probably be worded something like this. Okay? Okay, so you're rowing a boat due north across a river at 2.5 meters per second. Okay, the river current is due east at 1.0 meters per second. Okay, so in the question it says you are rowing this way. Okay, it doesn't say you are going this way or that you want to go this way. It says you are rowing this way. Okay, that's a rowing across question. Okay, the rest of the question might ask something like this. If the river is 200 meters across, okay, how far downstream will you be when you reach the other side? Okay, that's how a rowing across question is generally worded. A rowing across question may also ask you for the resultant velocity of the boat. Okay, and I can show you how to do that as well, but it's generally going to ask for something like this. Okay, so what we have is your your distance across is 200 meters. Okay, your rowing speed is 2.5 meters per second, and the river current is 1.0 meters per second. Right? Now, if the question were to ask you, what is the resultant velocity of the boat measured from the shore? Okay, then you'd be looking for this line here, that's our resultant velocity, but you'd be looking for that angle because that's relative to the shore. Okay. Everybody follow me on that? Okay. How easy is it to get that number? Pretty easy, right? I just have to do a Pythagorean theorem calculation and a trig calculation. Now, for me, I would probably just reverse this triangle. If I knew that it was looking for that, I'd just swap them out and go 1.0, 2.5, and calculate it that way. Okay? Or I could calculate the angle the other way and then go 90 minus that, and I would have the angle I was looking for, okay, either way. Okay, so if we did Pythagorean theorem on a question like that, okay, we would have square root of 2.5 squared, okay, plus 1 squared, which is 1. So I don't need to square it. Okay, so we're looking at 2.7 meters per second at whatever that angle ends up being. So inverse tan of 2.5 divided by 1 at 68 degrees north of east. Okay, because the question actually did say due north and due east, so I could give compass directions. If it didn't give me those, then I would say from the shore. Okay? All right, so that's something that actually wasn't written in here, but something that you could be asked. Okay, for this part, if the river's 200 meters across, how far downstream will you be when you reach the other side? Okay, so it's actually looking for the horizontal distance, okay, or the downstream distance. I have the across stream distance and the across stream velocity. What can I find with those two things? Time. Yeah, just like a projectile motion question. This is two-dimensional motion. Okay, so I would find what my time is by going t equals d over v, 200 over 2.5. Okay, it's going to take me 80 seconds to get across the river. All right, so my time is 80 seconds. The entire time, all 80 seconds that I am in the river, I am also going not just across, but also downstream. How fast am I going downstream? 1 meter per second. So if I'm in the water for 80 seconds at 1 meter per second, I'm going to end up 80 meters downstream. Okay, everybody follow me there? So that's how a rowing across question would work. Anybody need that before I take it off and show the going across? Okay, a going across question is almost always going to ask you about a heading. Okay, what direction do you need to go in order to end up going across? Okay, so it's always worded differently. Okay, it refers to going across, being straight across, ending up straight across. Okay, something like that. Never mentions that in a rowing across question. It just says you're rowing that way. Okay, so for this one, we have our river, okay, and we know that we want to end up with our resultant doing this. Okay? Doesn't matter how big it is, the question doesn't care about that. It just asks about the direction. That's what I want to end up doing. Okay? The two contributing factors to that are the river current, that's 1.7 meters per second east, and the rowing speed, which is 2.0 meters per second. How did I know to draw that way and that my result is not my hypotenuse? Because that's kind of the key to these. That's what?
You can move, so it's just factoring in the cars.
Right. Okay. If I'm going to end up straight across, that means I can't row that way. I have to row into the current and let the current push me back to straight across the river. Okay. That's going to slow me down a little bit. Because when I row at an angle into the current, there is a component of my 2.0 meters per second that is in that direction. And as a result, I am actually going to end up going across at slower than 2.0 meters per second, but I'm going to end up going across. Okay? So now that I've got that triangle drawn, can I find this angle? And that's what the question is asking for. I know the opposite side, I know the hypotenuse. Okay? So I would simply say that theta equals sine to the minus 1 of the opposite side, 1.7, over the hypotenuse, 2.0. Right, and that would give me my heading. Okay, so I'd have to really row across 58 degrees. I'm more than halfway into the current. Okay, so I'd be rowing almost like upstream, more upstream than across in order to make that happen. Okay, everybody over that? Dave?
So when we have these types of questions and we have to use like circuit or whatever, do we have to show like the manipulation to get theta by itself, or can we just put down theta equals sine negative 1 and then put the numbers in straight away?
I would always err on the side of showing your work.
Okay.
If something goes wrong and you type something in wrong, then at least you have your work that said, look, Coder, I'm not a total failure. I knew how to do it, I'm just really bad at typing, right? I'm being sarcastic, but obviously that's, right? You get something, okay? And I've had this argument with students before, and I always end up getting proven right, unfortunately, okay? I don't need to show my work, I don't need to show work, I always get this right, okay? That's great. If you have that kind of confidence, that's awesome. The only problem is, this is what I see happen. Final exam, I come around and I reset your calculator, you forget to put it back in degree mode. Happened to a kid. Never showed his work, I told him, show your work, show your work, show your work. Final exam, reset his calculator, didn't put it back in degree mode. Every single question that involved the trig calculation he got wrong because his calculator was in radian mode. How he didn't notice it was in radian mode because his answers made no sense, I'll never understand. But he showed no work, and he got zeros on 6 and 8 mark questions. He didn't show me any work. So I say, always err on the side of showing work. Okay? You can still get marks for work in Physics 20, take advantage of it. Diploma exam, they couldn't care less. That's unfortunate. Okay? But at least here, we can look at it and go, oh, they did know how to do it. They just can't operate a calculator. Well, I only have to dock them 1 mark for that. Okay? As opposed to 7. So make sure you show your work. Okay, what else?
Can you just do like a general weave style?
Okay, angled projectile? Okay. All right, so Okay. All right. So we're gonna do this one here. We've got our initial projected vector. It's 20 meters per second. Okay, it's angled 30 degrees above the horizontal. Since I'm not told otherwise, I'm going to assume launch and impact are the same height. Okay, so there's no change in height in this question. Things I have to remember about angled projectiles. The biggest thing I have to remember is that the two sides of this triangle represent these. The adjacent side to the angle is the horizontal component of the 20 meters, or of the projected velocity. This number doesn't change because the horizontal component is constant velocity. Okay? This side of the triangle is the initial vertical velocity. And it will change because the vertical component is affected by gravity and is thus accelerating motion. Okay? If we don't remember that, it's really hard to get things started. Okay? And the mistake I often see people make is they use this 20 meters per second for these numbers. Okay? That 20 meters per second is 30 degrees above the horizontal. It is neither one of those numbers. Okay? All right, so now I need to break this up into the two parts. Okay? So vertical information that I have. A is negative 9.81 meters per second squared. Okay? Horizontally, I don't know anything yet. I have to calculate some stuff. Okay? So, what can I calculate right now? Well, I can calculate V horizontal and I can calculate vertical initial velocity. So, V horizontal, which will remain constant because horizontal is V equals d over t, okay, is going to be the adjacent side to this angle. So, that'll be the cos of 30, okay, times 20. Okay, so we're looking at 17.32 meters per second. Okay, and then for VI, VI is the opposite side to that 30-degree angle, so that'll be the sine of 30 times 20, which is 10, positive 10 meters per second. Okay, now since the launch point and the impact point are the same height, what's VF? Negative 10. That's another thing that we have to be aware of, okay, because it helps us get that extra number.
Use that again.
Okay, if the launch point and the impact point are the same height, VI and VF are equal in magnitude but opposite in direction. Okay, for this reason. If I throw something up in the air and I catch it at the same height I threw it from, this is what happens. It goes from my hand at a certain speed and slows down, slows down, slows down, comes to a stop, and then falls back the exact same distance at the exact same rate of acceleration, so it has to reach the same speed it left at. Okay? All right, so we've got A, VI, and VF for our vertical part. We have V horizontal for our horizontal part, okay? And we're looking right now for the horizontal distance traveled. What do I need? I need the time. Okay, I can find that with my vertical information. So A equals VF minus VI over T. Okay, and so that'll be negative 10 minus 10. Whoops, sorry, I'm looking for time. Time equals VF minus VI over A. So that'll be negative 10 minus 10 over negative 9.81. So negative 20 divided by negative 9.81. All right, so this is going to be 2.039 seconds. Okay, that can come over here. Okay, D equals V times T, 2.039 times 17.32, and we'll have our horizontal distance. Okay, so we take that and we multiply by the 17.32050808. All right, so it's going to travel 35 meters horizontally because I only have 2 significant digits there. Okay, part A. Part B, calculate the maximum height. What 2 things do I need to remember? Actually, I only need to remember one of them because I'm only going to do this one way on a test. I'm not going to do it both ways, but there's 2 things I should remember about the maximum height. Right? So the maximum height occurs right here. What's true at that height? VF is equal to 0. Okay, what else is true at that spot? Exactly, it's half the time, right? And that's the mistake people make when they're using time for this calculation is they use 2.039 instead of half that number, okay? This occurs exactly halfway through the trip. All right, so we've got VF equals 0, okay? VI still positive 10, acceleration is still negative 9.81, and I'm looking for a vertical displacement. That's what height is. Okay, so I'm looking for the vertical displacement at this position here. So I'm going to use this formula, VF squared equals VI squared plus 2AD. Okay, I'm trying to find D, so I'm going to subtract VI squared. Okay, and then I'm going to divide by 2A, and that'll leave me with D. What do people mess up when they use this formula most often, do you suppose? They forget to square. Okay, when they use the other formula, they forget to divide time in half. When they use this formula, they forget to square. Okay, remember to square. All right, so we've got 0 squared minus 10 squared over 2 times negative 9.81. So in other words, we have 100 divided by 19.62. Okay, so this thing is going to reach a maximum height of 5.1 meters. Okay, if I was going to solve this using this formula, which I very well could, okay, and we saw the other day that even I'll forget to divide the time by 2, because I did that the other day, right? We'll take that 2.03 and divide it by 2, so we'll have 10 times 1.015, we'll say. I'm just going to, it's not really true, but okay, plus 1/2 times negative 9.81 times that 1.015 squared. Okay. So 10 times 2.03 over 2, okay, plus 0.5 times negative 9.81 times 2.03 over 2 squared. Okay, exact same number, okay, 5.1 meters. Okay. All right, what else? Okay, well, if you guys, if nothing comes up right now, hopefully something will come up here in a few minutes, but if you got some time to review, I did post that review package on Google Classroom last Friday, I think. Okay, so last week anyway. We'll have a look here, see if we can find it. Okay, you can be working on that right now. So there, September 28th. Okay, so it's the Unit 1 exam review package, and there's a key there as well, so there's questions, then the key. Okay, so you can be working on that right now, and if questions come up, ask, and I'll help you.